All right. So this is similar to what we were looking at yesterday. So we're going to review a little bit. So if we undistribute these or we take out the GCF, what could we take out of these three terms? What's the very most we could take out? Okay, so if we take a 6 out front, what's left? What's this? Are we subtracting? Are we dividing? What are we doing? Okay. Question? We could use 2, but we always want to take out as much as we can, and we can divide a bigger number out, which would be 6. Good question. What's the most we could take out of both of these terms? We can take out a 2, an A, and a B. That's the very most we can take out. So we're left with AB plus what? Close. Just 5. Okay, what can we take out of this one? So what do we have left then? What do we do here? We have to have a 1 there, because if you would have not written that and then we would have multiplied back out, we wouldn't have gotten what we started with. But if you take everything away, you have to have a 1 there. It's like a placeholder almost, so that when you distribute back through, we would have gotten what we started with. Okay? This one. What's the most we can take out? 2 is all we can take out. So we've got not 4. 2x cubed minus 3x plus 1. So this is always going to be your first step, is to take out anything in common that you possibly can for this whole chapter. So what can we take out here? What do we got then? Minus plus. What's left on this last term? Just an x. All right, this one on the left here, what can we take out? Take out a 4, we're left with 3xy minus z. And the last one. Take out a 4x. X minus 1. Good. Okay, so for the rest of this chapter, and anytime they ask you to factor, you have to take out the GCF first before you move on to the next step. Okay, so that's what taking out the GCF looks like. All right, so first we're going to FOIL. I'm only going to show you FOIL on one of them, and then we're going to do what's called the window method for the rest of it. So you may have seen this before in algebra. FOIL stands for first, outside, inside, last. So what that means is you're going to multiply the first terms, the outside terms, the inside terms, and then the last terms. So if I do that, the first two terms multiplied together, x times x is x squared. The outside terms is 4x. The inside term would be minus 4x. And then the last terms, you get minus 16. And then you combine like terms, and you get x squared minus 16. Questions on that? Okay, but for the rest of these, we're going to organize it in a window, and there's a really big reason why we're going to do this, because it's going to help us later. So when we have two quantities like this, if we multiply them like this, and just organize the two quantities across the top and down the side, what we're going to do is we're going to get the same terms here, but it's just organized in a square instead of in a long line. Okay, so what you do is you multiply the area of the square. So 4x times 4x, we get 16x squared, and we get 28x. Here we get negative 28x, and here we get negative 49. Now these two typically are like terms when we do this. Not always, but typically. And so we combine those. What do we get when we combine them? 0. So if we did get something, we would write it directly here in the middle, but there isn't anything. And your answer is always right here on the diagonal. So we've got 16x squared minus 49 for the answer. We'll do this one. You're going to want to get really used to seeing these windows for the window method. So we got x squared times x squared. What's that? X to the fourth. 5x squared. Negative 5x squared. And negative 25. These two cancel out again. You're seeing a pattern, hopefully. And the last one, 3x minus 6y and 3x plus 6y. 9x squared. Negative 36 y squared. These cancel out again, so we're left with 9x squared minus 36y squared. All right, so what's in common with all of these problems? Okay, they have something that cancels out. What else is in common? What's similar with all 4 problems? They all have exponents. What else? They're all minus on the answers, you mean? Yep, they're all subtracting on the answers. That's definitely something to point out. These are all the things I am looking for. Well, there's a few more things we're missing, but the things that have been listed are all good. What other things do you notice? Maybe about how each problem started. They are exactly the same. The only difference is one is plus and one is minus. Do you see that on all the original problems? Okay, those are all connections that we need to make because we're going to be now starting with this and needing to go back to what it started out as. So what is the connection between, what if we started with the red and we were trying to get back to the blue? How could we figure out what those would be? How could we go from these two terms and know that it started out as those? You're square rooting them, okay? Some would think you're dividing by 2, but you're not. You're just taking the square root of each of these terms, and you get the 3x and the 6y, for instance. So we're going to try that on these. Now, these are called the difference of two squares because you're always subtracting, which we talked about. And it's squares because they're perfect squares, so you can take the square root. Okay, without getting any decimals. You can square root. Okay, so looking at these. So now we're working backwards. Can we square root both of these terms right here? And are they both perfect squares? Yes, we can square root both of these things. Okay, so we're going to write our parentheses. What are both of them going to start with? The square root of r squared is r. And what goes here and here? 7 and 7. And then it doesn't matter if it's plus minus or minus plus. They just have to have one b of each. Let's jump down to this one. First of all, we should be always asking, can we take anything out? Can we take anything out of these two terms? No. Okay. So then we can jump right into the factoring. What would the square root of this first term be? 5t. So we'll start both of them with 5t. What about the square root of the second term? One's plus, one's minus, and you're good. Jumping down here, can we take anything out of both of these? How much? Okay, so if we take a 4 out, what are we left with? Minus. We're just taking a 4 out, so what would be left right here? 16. Divide by 4. Okay, so now we have this 4 out front, but we can factor what's left in the parentheses just like we were doing up here. So what would we get when we factor x squared minus 16? Square root, and then one's plus and one's minus. So when you take a GCF out, it's part of your answer, so you need to leave that in with your parentheses. So this chapter is all about kind of working backwards. All right, what about this one? This one looks a little bit different. Could we rewrite it and have it still be the same expression?
Yes.
As what?
X squared minus 9.
Okay, so if we change this, now we can factor this, because if there's addition in the middle, we can't factor these square root ones, difference of two squares. So we can now factor this to be what? You got x and x, plus 3 and minus 3. These tend to be the easiest ones to factor, but because we learn them at the beginning of the chapter, kids forget how to do them when we get to the test. So just remember, when you have two terms and they're perfect squares and you're subtracting them, you can always use this. All right, so this one, we can't take anything out. What would the square root of this term be right here? 5 r3 t b squared. So we'll copy that again. And then what's the square root of 1? 1. 1's plus, 1's minus. Okay, can't take anything out of these two terms. What's our answer going to be? What does each one start with? 4x squared.
Minus 9.
Okay, now this one I put on here because we're actually not done factoring. Do you see that? One of these we can factor again. Which one can we factor again?
The 9.
They both have 9s. What are you talking about? Which one?
X.
Why can we factor the one on the left and not the one on the right? Because these are called a difference of two squares. You have to see that subtraction in order to be able to factor it. So this one right here we can break down again.
See now? Do you understand now, Charlie?
So what would the two terms be?
2.
And then 2x minus 3. And then this one we can't factor, so it stays the same. So you need to watch out for that and make sure that you're actually completely done factoring.
See,
questions?
I saw it for
Hold on. So this right here is the answer because this one we were able to break down again, and this one we couldn't factor, so it's still part of the answer. Yes.
Just dividing it, or are we squaring it?
Square rooting it.
You can't square root a negative, can you?
We're just looking at the number itself, just the 9 and the 4x squared. So if you look back here, whenever we were multiplying these and one was plus and one was minus, it always ended up being a subtraction in the middle. That's why. Other questions on these? Yep.
On the 4x squared minus 64 on the left side.
Yep.
How come there's a 4 and none of the other ones?
Okay, good question. So all of these, none of them were able to take a GCF out like we did on the first page. This one, they did have a common term, so you always want to take that GCF out if you can. So it's like what we were doing on this page, where you take out what's in common. Other questions before the last page? All right, so we're going to try these. I'm going to give you a 2-minute head start, and we'll see if we can all get the same answers.
We can do this when we can.
Can we do it in our heads, please, and not think out loud? Thank you. Remember to take out GCF on any problems that you're able to. Got 1 more minute and then I'll start putting answers up here. You can factor that one just the way it is.
Okay.
Yep. I'll go through it in a little bit. Is that the only one you have left? All right, so not all of you are done, but we're going to go through this first one right here. What would this first set of answers be? Because this one you can do twice. Yes. X squared minus 4 and x squared plus 4. This one isn't done yet because this one on the left we can break down again. Okay, and then this one on the right we just copy down again because we cannot factor that one. So there is the answer. This one below it, what do we do? What could we take out? We can take a 4x out. This is also considered factoring when you take out what's in common. So what would be left over? Perfect. Can't go any further than that, so that is factored. This one.
X plus 8. X. What? Oh, we can't.
Can we factor this one?
No.
Why can't we factor it?
Because there's a plus.
Yeah, this doesn't fit the exact description of a difference of two squares. This is the sum of two squares. So you can say not factorable, or shorter than that is just writing prime. You can't factor it. Okay, the next one up at the top on the right, what should we do first?
Take the 2 out.
Take a 2 out. So we're left with 16x squared minus 25. Oh, that one worked out nicely because now we can factor it to be what? 4x plus 5 and minus 5 after we square root both. Can we take anything out here? So it starts with
5x cubed minus 4y.
and then we have 4y and 4y. What about the last one? We have the difference of two squares, right? Okay. What's the first going to be in each one?
11.
What's the second one going to be? 1's plus and 1 is minus. Questions? Okay, first thing is always looking for that GCF, and then you factor if you can.